Hello everyone, my name is Pat Stevens and this is presentation number 3 for AMGT 402. Today I'm going to be talking about the importance of properly servicing an air conditioning system and one very important step that needs to be followed to ensure its proper repair. Air conditioning is considered one of the most expensive repairs on a vehicle besides tires and your fuel costs. Typically, if you have a low charge or if you have some sort of a leak that causes the system to become inefficient, you have to find the issues and then repair them. More importantly, also make sure that you change your receiver dryer, accumulator, or reservoir tank, whatever you have in that system. The important thing here is to make sure that you have removed all of the oil out of the system, and that way that will guarantee a good repair. After you've proceeded through with the finding the leak, repairing it, changing your receiver dryer, one of the important things you have to do is make sure that you cap all the lines off while the system is open. Why this is critical is it cuts down on the amount of moisture that gets into the system, which means in the end it's less vacuum time, and it allows you to finish your repair quickly without having to do excessive vacuum time on the system itself. One of the things that a technician should be using is either a vacuum gauge or a thermistor gauge. The importance of this is it measures instead of measuring in terms of inches of mercury, it is actually measuring in microns. The target rate that you're looking for, according to the latest edition of ESCO Institute, the target rate you're looking for is 500 microns of vacuum, which equates over to 29.9 inches of mercury. The reason why you want to do this, the more pressure, or I should say, the more pressure you can pull out of the system, the lower your temperature of evaporation occurs, which allows you to boil your water out of your refrigerant oil. It also allows to pull any extra refrigerant out as well. That is critical. As I mentioned before, the other thing you want to do is you want to make sure that you change your receiver dryer, accumulator, or whatever you're using in that system as well. Most of those components are only capable of absorbing about a teaspoon to a tablespoon of moisture. The reason why you want to get that moisture out is over time, any water vapor that is in that system can combine with parts of your refrigerant, whether they're carbon atoms or hydrogen atoms, or fluorine for that fact. The water will get in there, or I should say not get in there, but the water will be present in the system. It will combine with some of the components of your refrigerants, and it will decompose into acid. Over time, this will actually allow the system to eat or be eaten from the inside out, which will lead to more leaks and obviously more expenses. So you can see why why it is so important to make sure that you hit that target recommended value of 500 microns, which again equates over to 29.9 inches of mercury for a vacuum. Typically, when you hit that target spot, today's machines are scheduled that once they hit that vacuum, they'll hold it for 5 minutes. If after 5 minutes your pressures do not rise to indicate that you either have more moisture in the system, or you don't have another gross leak somewhere, or you have refrigerant that is still in the oil that needs to be brought out as well. Once that happens, the machine will then hold another 2 minutes. If the machine recognizes that your pressures do not creep up, indicating any one of those three instances, then the machine will allow you to go ahead, add your oil, or, well, actually would allow you to add your oil and then charge the system to specs. So, as we're looking at the system, excuse me, it is critically important that you pull all the moisture out as possible. You don't have to achieve a perfect vacuum because that's going to be really tough. And one of the factors, or a couple of the factors that actually influence how deep of a vacuum you can pull is going to be the cleanliness of your oil that's in the machine, your ambient temperature, how big the system is, and if the system's been warmed up or not before you start to do this. That will aid in helping you pull your refrigerant out. So all of those factors combine to either shorten your vacuum time or lengthen the vacuum time needed. Again, this ties back to either your thermistor or your vacuum gauge. Now, one of the really important things with using either one of these, they're very similar in fact. When you tee it into the system, when you've achieved your vacuum and you are ready to go ahead and charge it, you need to pull either the thermistor off or the vacuum gauge off or isolate them, whatever you need to do. Because once you turn around and start charging that system, you are exposing that very sensitive test instrument to a high pressure spike. And typically what happens there is then the vacuum gauge or the thermistor stops working because you actually damage it. I can speak from experience. Thankfully it didn't happen to me, but in one of the dealerships I used to work at, my service manager purchased several of these gauges to make sure that we were meeting the specs of a proper repair on our air conditioning system. The problem is most technicians forgot to either isolate it or remove it out of the system, and then when they charged it, they destroyed the gauges. Today, they're a little less expensive than what they used to be. I remember back then, every time they destroyed a thermistor, because that's what we were using, it was a $400 expense, and at that point, they weren't worth fixing. You actually had to turn around and buy a new thermistor, and right or wrong, the service manager finally said, I'm done buying thermistors, just do the work and let it go. So, a very critical piece of equipment. Certainly you need to make sure you follow your procedures to the T. The other thing that is a good idea is to make sure that when you're charging or adding your oil back in, you really should have those test instruments out of the loop as well, so you're not contaminating the thermistor or the vacuum gauge. A couple of the sources of my information for this short presentation actually comes from a couple of air conditioning schools from Freightliner, R12, and a 134A school from Navistar. I also am a test proctor for both MAX, Mobile Air Conditioning Society. That is your 609 certification for mobile vehicle air conditioning systems. Plus, I'm a proctor for ESCO Institute, which we teach, or I should say we deliver the 608 certification, which will allow you to work on small appliances, mobile air conditioning systems, i.e. reefer units on trailers, and larger institutional low pressure chillers. So I have a fair amount of experience with them, and those are some of the sources that I've used for this presentation. I look forward to your comments. Thank you very much.